So back in geometry, or maybe even before then, you learned how to calculate the area of a triangle, which is this. The area is 1/2 base times height. Sometimes it's written as base times height divided by 2, but it's the same thing, okay? All right, let's go ahead and just do a quick calculation with that formula just to recall and remember how all this stuff works. So for example number 1, two legs of a right triangle have lengths 7 centimeters and 4 centimeters, and we want to find the area of that triangle. So let's go ahead and draw a picture of it once I find my ruler. All right, this is going to be a right triangle, and for the space that I have here, what I'm going to do is let the base be the 7 centimeters. Okay, so I'm going to let the legs be the base, and then what would be called the height here. We're doing 7 by 4, not going to fit. Oh well, I'll just let it be. All right, so we're going to, here, I'll just cut it off a little bit. It'll be all right. All right, so we're going to do 7 by 4. Has to calculate the area. All right, well, the design of this question basically gives you those numbers that you need. Okay, the area is 1/2 the base times the height, so it's 7 times 4. Okay, and then when you do the math, I would probably just divide the 4 by 2, which is 2, and then 2 times 7 gives you 14. So the area is going to be 14 centimeters squared. Okay, easy enough. But it was easy enough because we used a right triangle. See, the right triangle automatically makes two of the sides, the legs here, the base and the height. See, the thing is that the base and the height have to be perpendicular to each other. That's the only way it works. In fact, that's true for really any area formula that you see. At least two of the dimensions that are in the calculations for area will be perpendiculars to each other. So this one happened to just give this to us right away. Now, if you're looking at just a general kind of triangle here, that would mean that you know one of the sides and know the height as a perpendicular that sits inside of it. And it's possible to know that information, but it's also very limiting and kind of weird that you need to know a measurement that's inside of the figure just so that you can get the area. So what we're going to cover in this video here is there's an alternative way to get the area of a triangle using trigonometry. Now, it still requires you to know things. Okay, the original formula requires you to know at least a side and then a perpendicular to it. So you need to know a side, you need to have a right angle, and you need to have a perpendicular. So there's sort of like 3 things that you need to know. For what we're going to do with trigonometry, you're still going to need to know 3 things, but they're different. You're going to need to know 2 sides, you're going to need to know 2 side lengths, and you're going to need to know the included angle. Okay, the included angle just means the angle that sits in between them. So if I knew B and I knew A, and I also knew the angle that was here, that would still be good enough to calculate the area of the triangle. Okay, and it's going to turn out to be this formula here. Okay, it's going to still have a 1/2 like the other one. You're still going to have a product, but you can look at this extra factor as almost like an adjustment. Okay, so if I took 1/2 times A times B, all right, that would not be the actual area formula. Like, it wouldn't fit here because these aren't meeting at a perpendicular. Okay, but if I multiply by the sine of C, the sine of the angle that's located between them, that's going to make the adjustment, which is going to give me the correct area to this. So where we're going to begin is developing that formula. We can figure out where that comes from. Right. So I'm going to start by looking at the original formula that we have for the area of a triangle, which is 1/2 base times height. Okay, when I look at that compared to where I want to get here, which is 1/2 A times B sine C, when I look at that and the picture at the same time, 2 of these pieces are good. Obviously the 1/2, we see that. Now the B that I have here from the original formula, which is the base, is the same B that we see here, so that's all the same. The problem is that this has an H in it and that does not, but it has a bunch of other things that are in there. So off to the side, what I'm going to do is I'm going to set up another equation that's going to use the H it's going to use the A, and it's also going to use angle C. And I'm choosing all of those because H is part of the original formula, and the new one is going to have an A and a C. It's also got sine, but it's going to have A and C. So I want to use the H, the little a, and then the angle C that we have here. Now, all of those, the relationship is that they sit within this right triangle that's here. Okay, and with respect to C, the H is the opposite side, okay, and the A is the hypotenuse here, right? Opposite and hypotenuse. So that means we're thinking sine, right? That's going to get us to the sine. The sine of angle C in that picture needs to be the side opposite of it, which is H, divided by the hypotenuse, which is A. Now that might be a little bit confusing because we're used to the H being hypotenuse and A being adjacent, but in that picture, that's what these things are. This is the opposite side and this is the hypotenuse that we have. And what we're gonna do is solve for H. We're gonna solve for H, and by doing that, or to do that, we're gonna multiply by A. So if we take A times sine C, that's gonna give us H. So real quickly, I solve for H, and I wanna use that to substitute in for the H that we have in the original formula. So now I've got 1/2 B times A sine C. And if I move things around a little bit, because all this really is multiplying, it's 1/2 times B times A times sine C. If you move things just a little bit, we get 1/2 AB sine C. And for this, we just traditionally use the letter K to represent the area here. Don't know the reason for it, but that's just what we normally do. All right, and again, what this tells us is that to figure out the area of any triangle, you can take 1/2, the product of any two sides, multiplied by the sine of the angle between them. And if you do that, you'll get the area of the triangle. So it gives you another option. It doesn't mean that it's easier to do the problem with trig, but it gives you another option in case you couldn't do it with the traditional formula. For example 2, let's go ahead and try out the formula, see how it works out here. We have a triangle DEF, and little d and little f are things that we know. So little letters, of course, are going to be the side lengths because the capital letters are the vertices, which we'd also use to represent the angles. So we've got two sides here, which will be the 9 and the 10. That's D and F. We also have the angle E at 102 degrees. Okay, when I draw the picture, I'm not going to worry about making it look perfect, but I'm going to at least acknowledge the fact that I've got an obtuse angle here and go ahead and draw an obtuse angle. Okay, so it doesn't need to be perfect, but we'll let it be. You can try to be as perfect as you want. That's fine. Okay, so this is 102 degrees, and that is definitely angle E. Okay, so these are going to be D and F. In my picture, I don't know if I can really tell which one's longer or not. They're also fairly close to the same number, so I'm not going to worry about which is which. In fact, you don't even have to spend so much time making your pictures look perfect. You could just do a really quick picture of a triangle and get everything filled in. All right, so everything's filled in, and if we're asked to calculate the area of this triangle, then everything has actually been provided for us perfectly. We've got two sides, and we have what's called the included angle that's between those two. So we'll just fill this into the formula. K is going to be equal to 1/2 9 times 10, that's the two sides, times the sine of the angle that would be between those, so 102 degrees. All right, and all that you can just type into the calculator, you get an answer, but there's some things that are always easy to multiply, so I just go ahead and do it. 1/2 times 10 is 5, 5 times 9 is 45. Okay, so that the whole piece is just, you can do it as mental math, save yourself some time. So we got sine, so we got 45 times the sine of 102. Now at that point, I'm going to need to type it in because I don't have any other way of evaluating what the sine of 102 is. Okay, so I'll take 45 sine 102. Again, make sure you are in degrees. And we're going to get 44.01 we'll just go ahead and call it 44. So this will be 44. And we did not get units for the area, so I'm just going to write a letter U, but it's units squared. It's 44 square units of area there. So example number 3 is an interesting one because it has 2 answers that go with it. Okay, what we're provided with is a triangle called PQR, and we know that its area is 15. We've already got the answer for the area, it's 15, and we know that 2 of the sides, P and Q, are going to be 5 and also 10. What we're going to do is figure out what the angle would be for R. Okay, now let me do a real quick sketch of a triangle just to organize things. So I'm not even going to worry about drawing it straight. All right, let's call this PQR. And little p is going to be the 5 that's here. Little q is going to be a 10. And then you're asked to figure out what angle R is, which is here. Okay, so what I want to notice from the picture and show you is that the angle that we're looking for is actually the included angle. That's here. So this is going to work good for the formula that we have. Okay, so the formula is k equals 1/2 AB sine C. The k is given as the 15. The 2 sides that we have are 5 and 10. And we're asked to figure out the sine of R. So I'll go ahead and write R in there because that is our included angle that we're looking for. All right, 5 times 10 is 50. Cut that in half and you get 25. So we've got 15 is equal to 25 sine R. So again, some things I will do just as mental math because we'll save some time. Next, what I'm going to do is divide the 25 to the other side. So we have 15 over 25 is equal to the sine of R, which you can reduce the 15 over 25 if you want. That will reduce to 3/5 if you divide by 5s. Not quite necessary, because what you're going to do, at least once you get to here, or you can do it with the numbers we get there, is we're going to use the inverse sine or the arc sine to figure out what our angle is. So I'm going to press second sine, type in 3/5, or you could just do the 15/25. That'd be fine. And you get 36.9. That'll be fine. So R is equal to, what do we say, 36.9 degrees. Okay, but there's actually 2 answers. So it's like, well, where does the other answer come from? Okay, in a different video, I'll talk about when you're using inverse trig functions and how you can get multiple answers that go with them. So we really haven't talked about where that comes in, and this will just be the first sample where you get to see it with the inverse sine. All right, so to demonstrate, what I'm going to do is attempt to draw a picture. I'm not going to draw it using exactly those units. I think I'll kind of shrink it a little bit. Let's do the base here. So I'm going to use 6 because I need to make the other side half of that one. So I'll just let that be PR. I think that's going to fit pretty good. And then the angle that we solved for, I'm going to use that. That's at about here. Okay. And now that side, this side right here should only be 5 compared to the 10 that we had on that one. So I'm going to line this up, and half of my base is actually going to be 3 centimeters. So that'll be the 5, and I can close it here like that. Okay, so that's the picture that we're really thinking of when we get our answer, 36.9, like that. Okay, so here's the other answer, which is really interesting. It's actually the supplement to that one. It's actually the supplement to it. Let me go ahead and start drawing a little bit of this first. So there's my base. What was that? That was R, so this was Q. So we got P, we got R, and then there's going to be a point Q. But we're not going to measure 36.9 degrees that way. What we're actually going to do is use the supplement to it. Let's get lined up. The supplement to that will be 180 minus the 36.9. Let's see, type that in real quick. Actually, I'll just subtract 180 from that and then take the negative. So at 143 degrees. And all this is going to be explained why it works in just a moment. Okay, so that's at about 143 degrees. And then I'm going to measure out my, it'd be 5 units, but I'm using 3 centimeters here. Get my line up. So that's going to be Q. And now if I close this off, get these all labeled up real quick. 10, 5, and we did about 143. We'll just call it that. Don't worry about the decimal. I think it's 0.1. Yeah. Okay. These actually have the same area, and they both fit the same description. We have the two sides, and we solve for an angle in between them. Now, how do we actually confirm that these are actually, the same area? How do we buy into this as the answer? Well, remember that the original formula for the area of a triangle is 1/2 base times height. Okay, so both of these have so 1/2 is 1/2, that's fine. Both of these have the same base of 10. They actually do both have the same height. So I'll start at the base, and then I'm going to move my ruler parallel to the base, and you're going to see that they actually do have the same height. It's sort of like that segment, instead of being positioned there, is going to swing out, get higher and higher and higher, but once it gets to the supplement measurement, it's actually going to be at the same height as the original. So when you're doing one of these problems and you're solving for the included angle, there are 2 possible answers that you can get. The one that the calculator will give you is an acute angle measurement. The other is going to be the supplement to that one.
Wait, what?